Hi friends, welcome to TechieMit. Today we'll start a new video series related to whiteboard recording videos. So basically it creates new object in the heap memory. This is basically a heap memory. And the initial capacity we called also the size of initial. The HashMap size is 16 initial capacity. And so you must be noting that 16 it's the so where these 16 nodes or elements might be stored, so they are basically stored in a linked list. And the load factor is 0.70 or 75%, means when HashMap with the initial capacity 16 it reaches 75% of its total size, that is 12, resizes itself to double, so it will change from 16 to 32 size in the memory. So when 75% of the HashMap filled, it resizes itself to redo. So that was about linked list and how the what is the initial capacity and load factor. Now comes the important part, that how the HashMap identifies when and where to store the location in these 16 buckets, that specific node. So basically HashCode is that integer that is generated using some algorithm. So it basically used to identify the bucket location. So when you HashMap basically invokes the put method. Suppose consider this is a HashMap created. Let's say we create of integer. So HashMap dot put so basically when we invoke put method is invoked dynamically with the use of HashCode method, it identifies where to specifically that particular element needs to be stored in the linked list. So let's say in the 0th, it generates a HashCode as 2002 and it stores in the 0th location of the basically initially 16 capacity. So it stores here. So using HashCode 2002, suppose there is a number with 2002 HashCode, it will store over here. Now comes the point, so what if there are more than one HashMap instances or objects with the same HashCode value? So suppose we have 2004 and there exist two elements with same hash value. hash value or hash code value, you can say. Such a situation arises in the case of hash collision. So this situation is called hash collision. What will do? It will identify two nodes with 204, and it will store the new node adjacent to this node. Let's consider this as map 1 and map 2. So this is basically a situation in which hash collision has occurred, with the hash collision being 204 for two elements or more than two objects. So it will allocate the new node with the same hash code adjacent to that previous node. So this is how hash collision is handled in HashMap. So if some element with the null is as a key, because one null key is located, so it will store in the 0th location in the HashMap. Also, so this was about hash collision. So such situation is okay if there are few number of nodes or few hash collision occurs. So what if there are n number of nodes in which hash collision is occurred? So whether this existing data structure principle would be efficient to handle that situation? Certainly not. So here comes into the picture using Java 8, that is red black tree, binary search tree. So what is that? Let's see it. So before we know the details of red black tree or binary search tree, it is necessary to note that the by default red black tree or binary search tree is not invoked in a hash map. By default only linked list is available, but when it reaches some minimum threshold called as 35 threshold, so basically the value for HashMap is 8 in Java 8. So there are 8 or more number of hash collision, and it basically resizes itself from red black tree or binary search tree. From linked list to red black tree to or binary search tree. So basically, what is binary search tree? So there is some base node. Let's say 2. Element that is higher than 2 will go on this side. So 3. We have one over here. So for demo purpose, I am just showing the integer values. So to keep it simple and easy to understand. So it will compare with the base node. This being the base node. The value that is greater will go to the upper side, and the value that is the lower will go to the downside. So 1 and other values will go over it. So similarly, it can contain n number of nodes over here. So according to how the elements they increases, it stores itself, and the hash collided elements are stored over here in the red black tree binary search tree. So this is good in the case of integer. What if it belongs to some other data type? Then we using the compare to method. So compare to method is invoked to check the base value, be it string value or character value, and using the compare to the value which is higher will go to the upper side, and which value it is lower, it will go to the downside. So the advantage, the main basic advantage over here is, suppose there is an element I have to search as 1, this specific element. So I will just need to know the base node, that is 2, and it will directly point to the next node as 1. So it has speed advantage over linked list when it comes to a number of nodes or n thousand number of nodes, as your linked list or HashMap database grow to any size. So in that, over here, just using the base node, you can able to locate that specific node very easily. You need to, this is over where the get method comes into picture. HashMap.get methods will move, and you will get the specific node in that red black tree binary search tree. So this provides an advantage of speed advantage in compared to linked list. So this video was all regarding the internal working of HashMap. So do keep liking, subscribing. #TechieMit, more videos to come on you related to screen, more related videos also. My goal when I will be explaining more concepts.